As Deputy Director for European Forest Institute in Joensuu. His title today is Impacts of Different Forest Management Practices on Forest Carbon. Please, the floor is yours.
Thank you, Jari, and I also want to thank the organizing committee for inviting me and for giving the opportunity to talk about forest management practices in European forests and the impacts on carbon. And I will try to put this as well in a somewhat larger frame, not only talking about carbon, but also about the issues that affect forest management. So first I will say words about the principles of carbon sequestration in forest, the dynamics that we see. Then I will take you through the previous IPCC assessment and the carbon sequestration potentials which were published in there. And then we take you back to European forest specifics and tell you about issues in European forests, how they frame the carbon dynamics, and show you some upscaling studies. First, something about principles of carbon sequestration in forests. And generally there have been always in the studies three options to increase carbon. It's either an increase in area, an increase in carbon density in the forest ecosystem, or an optimal use of products. And carbon, as I will continue to emphasize here, it is not only carbon in the forest ecosystem that we look at when we want to store carbon in the ecosystem, managing the fluxes in and out of the forest ecosystem in biomass and soil organic matter, but it's also the whole forest sector that we look at. Through the forest management, we produce wood products, and those products can also compensate or can replace other materials, and in that way also reduce the carbon emissions from, for example, building with concrete or building with aluminium or glass. So in that way, you replace other products and you can have an influence on the carbon balance as well. Wood products, after their lifespan, can be abandoned and then still serve as for biomass, for bioenergy, or any other biofuel. And in that way, they replace fossil fuels, and safe fossil fuels can have this carbon substitution effect also through the energy market. So that enlarges our system. Again, it's not only the forest ecosystem and the products, but it's also the services for society that are incorporated in the system. And it's the variety of studies in the past where I think in the 80s, early 90s, studies especially focused on this, and then later on included wood products, bioenergy, and also the substitution effect later on. But by having demand, for example, for bioenergy, you have an influence on forest ecosystem and a certain demand for wood for bioenergy, and that again influences prices and has an influence also on the border between agriculture and forest in the landscape or in a country. So it's not only the forest sector, but then you also start to look at the whole land use sector, broadening the scope again of the analysis. Yeah. So I start with a simple example of a 1 hectare scale forest system over time. Here you see in blue, this is Norway spruce in Germany, how the biomass builds up over time, quite fast growing system, and within about 100 years you reach about 170 tons of carbon in the forest biomass system. So part of this scheme which I showed before. Then at the end of the rotation, the stand is harvested, and in red the wood products are produced. They decay with a certain lifespan, next rotation. At the end of the next rotation, you still have a certain share of wood products still in use, and that's added up to the biomass which you see then in the forest. At the end of the rotation, slash is produced, which you see here as a green spike, which is in the part of the soil pool. But as I said, wood products can also replace a more energy-intensive system and products, and thus have either a bioenergy aspect or a material substitution aspect, which is the yellow part. These, the red and the yellow especially, keep increasing rotation after rotation. So you have a very dynamic system in which carbon keeps fluctuating, and people very often ask, well, at the end of the rotation, don't you lose your carbon? Yes, you lose your carbon, partly, but at the same time you start building up a new system, and you do bring the whole system to a higher level of carbon in an equilibrium. So you do go from a system with 50 tons of carbon up to a system here with 300-400 tons of carbon. So you see these temporal fluctuations, you can see them back in the landscape. As you see here, you see it back as spatial variation. So temporal variation at the hectare scale is what you see back in the landscape as spatial variation. But very characteristic for these carbon sequestration discussions, also in maybe in respect to the policy arena, you and FCCC discussions, is that through time discussions and analysis become more and more complex. So the simple system we had earlier on is here in the rather simple assumption that when you produce bioenergy from woody biomass, that's carbon neutral, is now taken on in the discussion, and especially highlighting the carbon depth component of producing energy from woody biomass. The carbon, and I explain this through this example. This is a salvaging mountain pine beetle, dead wood in British Columbia example. At first you have a living ecosystem in green, then the mountain pine beetle attacked around 2003, 2004, and you produce a lot of dead wood, standing dead wood. Still some living trees there as well. But then, through the demand for bioenergy, this hectare is salvaged. My battery sometimes goes there. This is salvaged, and the yellow part is where you produce wood products and pellets from the standing dead wood. But by doing that, you do take carbon out of the system, and you do emit carbon by burning that wood earlier than when it would decompose in the forest. And that is this sort of upfront carbon debt that you build up by having a higher demand for bioenergy. And that is shown here. This is the red, the break-even point. You have a regrowing forest, so eventually you bring carbon back into the system, but you salvage it earlier. So that is your carbon debt, which you see here. And in this case, this is sort of compensated around 30 years. So you do bring carbon earlier into the atmosphere, which is simply seen in the atmosphere and counts as any other carbon. So in the discussion whether to burn fossil fuels or woody biomass, this carbon debt issue is becoming very important in the policy discussions. Because this is exactly the time frame that policymakers are still interested in. If we would massively go into biomass for bioenergy, it does bring carbon into the atmosphere just like fossil fuels. A little bit about IPCC. For understanding what we can achieve for carbon sequestration in forestry, it's very important to understand the history of the forest in that region, and in that continent. And what we certainly highlighted in the IPCC assessment is that every continent in the world has different options. For example, in tropical Asia, carbon emissions these are still emissions from deforestation, are very high. So that is the mechanism that you want to change, if you want to change the emissions to the atmosphere. But, for example, the USA has a totally different history in forest history, where in the 1700s and 1800s, the colonists very quickly moved from east in the US to the west, and large-scale deforestation took place. This is the deforestation time. And then part of that land was given back to forest or abandoned and started to regrow. This is the green part. So it's this regrowing forest which is your mechanism to tackle there. A totally different option how to increase carbon in the system. Europe has a bit of the same. Of course, the deforestation took place much earlier, maybe already in the Roman era and in the early medieval times. But Europe has since the 50s also a regrowing forest. So it's that mechanism that you have to tackle there. That is what we highlighted in the IPCC assessment. And that then gives totally different potentials by continent in the world. Europe, we think, well, has already quite a lot of woody biomass, has already quite a lot of area under forest, so the options to increase carbon there are not very large. It's in the deforested, in the deforestation where we felt, where we saw especially the options large for reducing emissions. A little bit about different sectors in the fourth assessment report. Here are the sectors at forest, and here are the potentials in at certain price levels, under $20 per ton CO2, under 50, under 100, and then you see the options usually and the potentials increasing. Forestry, we took a rather critical look at. Stands out as an intermediate sector where there are still large potentials, but other sectors in industry and buildings for agriculture, the potentials were estimated to be much larger. But I think it's also in this multi-sectoral view that I also mentioned in the early slide. That is what we also highlighted in the fourth assessment report. It's not forest as such, but it's in the whole land use sector and energy relations. Now, something about European forests. This is a tree species map for Europe. This lightish green is Norway spruce in Central Europe. The brown is oak, mostly. This reddish is beech in the Balkan. Here in the north Central European plains, it's Scots pine mostly. In the very north, Scots pine and spruce. Very characteristic for Europe is this intensive relation with human management. Hundreds of years of management already, and dating back already this deforestation era, as I said, in the early medieval times, or even a bit earlier. So a large variety which is also created by human management, and a variety which is also caused by different cultural, historical settings in the different countries. I think that's very characteristic. Some 177 million hectares of forest, almost 42% of the land covered by forest and other wood. The forest mostly kept in a relatively young state, fast-growing state, characteristic for this management influence. A rather a reasonable increment of almost 5 cubic meters per hectare per year, and that increment we saw has been increasing in the past. And this increasing increment in the past and the intensification of management in the past, the investments which have been made in site improvement, in provenance selection, this has caused really this increase in increment since the 50s. And because harvest is less than increment. We have been building up carbon stock in European forests, and this shows the net carbon sink over time since the 50s to 2000. And this is the carbon sink in the biomass. You see that that has been increasing quite fast. And with that increase in biomass, also the soil pool started to increase through more litter input over time. And these spikes downward are the storms in 1990 and 1999. And that, of course, this sets also the frame for how much we can achieve still in the future. Thinking about carbon sequestration, it is framed by management issues in Europe. And what I said earlier, carbon stock, growing stock keeps increasing in European forests, and that also makes forests vulnerable for disturbances. Here you see the volume of storm damage over time, since 1860s up to the year 2000, where a couple of large storms really stand out in the recent decades. It's maybe not climate change as such, which has caused this, but it's this changing state of European forest. It is large stocking available, makes the forest vulnerable to storm damage. And society also wants a more nature-oriented management. Certainly in the 70s and 80s, society started to question forest management in Europe and did not want this only rational, production-oriented forest management anymore, but also wanted biodiversity in the forest. And that has resulted in changes in policies, for example, the implementation of Natura 2000 schemes over Europe. This will have an influence on forest management and thus also influence the carbon sink. Society wants more nature in the forest, but at the same time society also kept increasing consumption. For example, this is the newspaper consumption per capita in kilogram per year versus the GDP per capita. You see clear relations per country, how with increasing GDP, increasing consumption really follows, up to a certain point. And we've already seen in the past that this was curving off, but now with both an economic crisis and also changes in the lifestyle of people, changes in how we read our media, this also has a structural change in this relation between consumption and GDP. Are we then, given all these issues, are we really doing a good job in forest management in Europe? And we tend to always sort of say how good we are. We have 300 years of sustainable forest management since von Karlowitz wrote his book on the Züchtung der wilde Bäume in 1713, now exactly 300 years ago. And we are so proud of that we have increased growing stock and we have increased production, sustainably managed forests. But there are still challenges, I think. We need 42% of European land to produce 3% of the European GDP. That makes our sector quite weak in respect to other sectors. Increment is at the moment going down. Apparently forests are reaching a sort of an equilibrium, high stocking, and increment is going down. There are signals that the sink is saturating at the moment. In the market, we generally have a bad connection between supply and demand. Forest owners are not very well organized. The connection with the demand side, with industry, is rather ad hoc. We only have rough insight in actually what the resource is out there. If we had much better insight, we could make much better use of available data, we could much better link supply and demand. We have these conflicts over forest functions. Should there be nature conservation? Should there be increased production? those keep coming up, and it's discussions like the carbon depth, which are a result of these kind of conflicts over functions. So we certainly have challenges as well in if we want to increase carbon sequestration. I will say now a little bit about the carbon sink potential, but what I have highlighted so far is this variety across Europe. And depending on the circumstances, that determines what you should do in order to increase carbon sequestration. Here is a series of maps on different parameters, and I'll say something like this is an elevation map, and this would be areas that if you want to increase carbon sequestration, these are usually areas where you have protection forestry. So these are areas where you want to continue to keep your forest cover and maybe do selective logging there. This is the forest area map, and the stocking map is here. This is the availability of biomass for bioenergy map. In Central Europe you have very high stocking, sometimes national average growing stocks of over 300 cubic meters per hectare. These are areas where you may want to bring down the stock in order to decrease also disturbance risk. By bringing down the stock, you make wood available for maybe biofuels, high quality biorefinery products. This is what you would do in Central Europe. This is a fire map, especially in the south, of course, affected by fire. If you want to maintain carbon in the system, this is where you want to reduce your fire risk. This is the urban area map. Usually around urban areas there's some urban sprawl, there is deforestation there. These are maybe the areas where you want to reduce deforestation. So it really depends on what are the circumstances in which region that determines your carbon sequestration potential. Now the last part is about upscaling some of these issues and some European scale analysis. I will mostly say something about studies for which HENVI model has been used. That's a large scale European scale forest resource model in which the national forest inventory data have been built in for all the European countries, and through management regimes, you can project the forest resource into the future at a from a rather detailed level up to European scale summaries. And this is one example on carbon. This was done by Nabuurs et al. Here you see the three carbon stock change, so your sink in European forests in the initial stage around 50 teragram of carbon, compensating about 7-8% of all European fossil fuel emissions. But under a very large demand scenario, so a large demand for wood, this sink collapses quite fast, which is a signal of this carbon depth issue. And then after some time that sink maintains at a certain level. Through climate change, in most regions an increased net primary production is foreseen. This sink can be maintained at a bit higher level, but still it seems to saturate there. Under a much smaller harvesting level, this sink is maintained at a higher level and does not turn into a source like here, but is maintained at a level of around 20 teragrams of carbon. So by playing with management, you do have an impact on carbon sink over time, but its impact is not very large. You cannot, within realistic schemes for what you can manage in Europe, you cannot have a dramatic impact on your carbon sink. Another aspect of this is this increased demand for wood that we foresee, maybe for the traditional industry, but also for bioenergy, that has also been quantified. How much can we potentially get out of European forests? Current harvest is close to 600 million cubic meters in total from stem wood. How much can we realistically increase this harvest over time? This was done by Hans van Gerk, also present here. First, they calculated the theoretical potential from European forests, especially the increases there in stumps and logging residues. And then they built in constraints, like in certain areas there are limits because it's a wet site. There are areas where there's a limit because of steep slopes. There are other areas where there are limits because it may not be accessible. So it's this combination of management constraints and biodiversity constraints, soil constraints, that then lower this theoretical potential up to a very modest, in a high mobilization scenario, still only a modest increase in what can be mobilized as stem wood, and a bit of an increase there in stumps and logging residues. So this gives a rather modest insight in what could be realistically achieved from European forest in producing this extra wood needed. So far I've concentrated on the carbon sequestration aspect. Now I will also show the last example of these carbon sequestration or forest dynamics aspects under climate change. First, I start with a climate envelope model that was done by Nick Zimmerman in the Mark Hanewinkel paper. In a climate envelope, you give a species a certain climate requirement that it needs to grow. Given if that climate then changes over time, that species will simply have to follow. It does not look at whether that's realistic or whether that's possible. It just simply follows the climate. It doesn't look at the transition steps needed. This is current distribution of Norway spruce. The reddish is where it's most common now. And then when I click through, this is 2010, 2040, 2040, 2070, 2070, 2100. Under that was A1 scenario. A dramatic shift of species range, I would say. This is what the climate envelopes tell us. We have used this information, connected that with the species in this HENVI large-scale forest resource model, in a way that we assume that when this model indicates that the species is not there anymore, that then in a realistic way the forest owner will start to change its species through regular management. So we have combined this more theoretical exercise with the more realistic management regimes in HENVI. So it takes only through rotational changes that new species can be introduced. And then we also incorporated primary production change from Christopher Ryer. Combine that with the demand change here, and incorporated these new management regimes. So it's a proactive change what the forest owner will do. We assume that the owner sees the signals in the field, and then at the end of the rotation only takes the decision to change tree species. And I will show you some of the partly gridded material. I only show you growing stock over time. Maybe it's best if you just keep an eye on this graph. This is on the climate change. with this adaptive management incorporated. And I'll click through quite fast. I hope you saw that. No, I'll do it again. What you can see, this is growing stock in Europe, with high stocking in Central Europe. And what you gradually see is that especially in this region, this is where we foresee quite these significant tree species changes. So there the forest owner starts to respond with a slightly increased tree species change over time. So they reduce slightly the rotation length in order to adapt to climate change. And that then brings a new tree species, but also smaller growing stocks over time. And what you then can also see is that the growing stocks in the north then eventually start to increase because of the net primary production changes there. You see? Good. Okay, the last one. European forest sequester a significant amount of carbon. The carbon stock is large already. Additional sequestration is limited in Europe, we think. It's the combination of this combination of subtle forest management changes, as I showed with all these maps across Europe, doing different things at different locations. It is these subtle combinations of forest management options and wood products optimization that seems like a promising option for Europe. Every location asks for this specific management options. We very often have this question like, what is the best thing to do for carbon sequestration? Well, there is simply no answer to that. It really depends on the circumstances and the history in your forest management. I will also show you this adaptive forest management that slowly sort of pre-adjusts for climate change. I fully agree with the previous speaker, Ulo, that there is a huge plasticity in the population and in the individuals at the moment, and it's only through realistic management changes that the whole system slowly adapts. Concerning carbon, and probably Constance will talk about that in the afternoon as well. What we see in the UN negotiations, they have been dragging on for a long time now, and that is a very difficult arena for forest owners or the forest industry to really judge what will happen, which carbon credits will be granted, which not, and that has, from a very large interest in ARD, when the start of the Kyoto Protocol, this has slowed down very much. Then the discussion took on to RED. That seems to be also at a difficult point at the moment. And now in the bioenergy discussion, this carbon debt issue came up as well. So it's issue over issue that's really difficult for the sector to deal with. And that's it.
Thank you very much. We have about 10 minutes for questions and comments. Are there any? Yes.
Kari Ninkkinen from the University of Helsinki. You showed this one picture about the potential for increasing the carbon stock in the wood products. It's working. So it showed quite a positive picture of the amount of carbon in the wood products. Was that kind of the situation now, or was that based on some idea if we start using the wood for buildings rather than pulp and paper, which is the kind of fact nowadays?
Yeah, that was one of these first slides, wasn't it?
Yeah.
Yeah, that was indeed the hectare scale analysis, and I would agree with you that that was rather on the high side. This reddish part you probably mean. This is it's a Norway spruce in Germany, which produces quite a lot of saw logs. And for the saw logs, I think we assumed like a half lifetime of 40 years, which is a bit on the longer side. And that indeed gives this picture. If you would do this for producing pulp logs here in Finland, with a lifespan of paper of 1-2 years, then you would hardly see any wood products. That's right.
Yeah, and if you look at the other picture you showed, which was the kind of situation of wood products in the during history, it shows that the wood products is actually quite low, and it's not increasing at all.
Yes.
So I think that's kind of measured situation.
Yes, that's right. And I would indeed, the woodworks are red here again, by coincidence. But this is indeed a very small fraction of the standing for the biomass, and I would have more confidence in this fraction here.
Okay.
Yeah.
I thought it was interesting that in the storm events in the early 90s, that the sort of the rate of uptake with respect to the sink recovered fully eventually. I mean, it's not surprising, I guess, because you have the regrowth coming after the storm.
Yes.
Is it fair to say that the stock itself actually recovers fairly quickly? And so the storm event is sort of just a temporary damage?
What happens here is that indeed this is the annual sink, and it's in this year, 1990, that the storm event took place. So that really changes this balance between increment and harvest. The storm adds this additional harvest, and so the sink in that year is really diminished. But as such, even if the storm damage was 100 million cubic meters, compared to the total stock of wood in Europe, that's really minimal.